Welcome to Bite-Size Data Science. One important aspect of data science is data exploration to get familiar with their characteristics so we can figure out what can be used and what is missing. Also, no matter where the data comes from, we should never assume that it is completely accurate. The exploration allows us to verify the quality of the data. In this video, we'll use Python and a Jupyter notebook to do the exploration. In a parallel track, we have the same processing using Spark, Python, and Jupyter Notebook in another video. You may wonder why having both. It turns out that in some cases, you don't necessarily need Spark. Think about it. Laptops today often have 8 or more gigabytes of memory. Servers can have a lot more. You don't always need to use a cluster to process your data. So here's an example of data exploration that uses Python and the Pandas DataFrames to do similar processing that is done in the video on Spark data exploration. The data we're using is a dataset of accidents in the Chicago area available at data.cityofchicago.org. The data was exported as a CSV file. The file was then zipped and put on GitHub. The goal of this example is not to show you how to do specific things, but to see what can be discovered while getting familiar with our data. We won't point out everything, but enough to give you a good idea of things to look for. We first verify that we read the data properly. We have 221,600 records and 48 attributes. Looking at the schema, we can see that the crash date and date policed notified attributes are objects instead of timestamps. We need to fix that before we move on. The Pandas DataFrame object allows us to easily display the number of non-null values for each attribute. The first thing we notice is that the crash date estimate has only 16,521 non-null values. This represents only 7.5% of all the values. This seems to indicate that this attribute is not very useful. Other attributes have low counts too. The describe method gives us some basic statistics of each attribute. We see that the posted speed limit varies between 0 and 99, raising a red flag. We'll get back to it shortly. The next thing we checked are the two date attributes. We saw that the crash date starts in January 2014, when the date police notified starts in July 2015. That's an issue that needs more exploration. Another interesting Pandas method is the nUnique one. It gives us the number of unique values for each attribute. That gives us interesting information. For example, the posted speed limit has 35 different values. Some other attributes appear to be multiple choices. Fields like traffic control device, device condition, weather condition, lighting condition. That raises multiple questions like, is the attribute non-null count makes it relevant? How many different values? Is there a value that could be considered the equivalent of a null value? This could greatly reduce the usefulness of the field. These questions are relevant for many attributes. We won't cover them all here. When we looked at the basic statistics, we saw that the crash date starts in January 2014 when the date police notified starts in July 2015. Can we assume that they should be within a few days of each other? Obviously, this is not always true. We find that the largest difference is 1,460 days and that we have 427 records that have a difference larger than 30 days. The number of suspect values is not very high, representing less than 0.2% of the values. We may either want to fix the values or simply eliminate these records in the case where we want to use the relationship between these two attributes. Earlier, we saw that the speed limit varied between 0 and 99. This requires more exploration. We find 35 different values. How do we address this? Do we consider 0 and 99 the equivalent of null values? Do we round up or down values so they match more common values? Do we go find a dataset that could allow us to correct the values? It all depends on how useful the speed limit will be in our modeling. Another important tool for exploration is visualization. We can display bar graphs that show the streets with the most accidents. We can also use a scatter plot to show the accidents in an XY diagram to get a feel for the distribution of accidents. We can also enhance the results by color-coding accidents by types, material damage, injuries, and fatalities. We can even use machine learning and mapping libraries to explore accident grouping. For that, we can use the k-means machine learning algorithm and start exploring grouping. This first map shows 10 groups. Of course, with 221,600 accidents, using 10 groups is likely not the right thing to do, but if we do the same with 180 accidents with fatalities, 10 groups may provide some insights. Why would you do this grouping? Maybe an insurance company wants to use the closest group of a potential customer home address and the closest center to that person's work address as one factor that impacts the setting of car insurance rates. Maybe the low number of accidents in an area could increase house values. In this video, we saw how data exploration can impact what we do with the data, informs us on the quality, the potentially missing information, and can give us insights on how to use the dataset through visualization. Remember, 80% of data science is to find, explore, and prepare data for modeling. See you next time on Bite-Sized Data Science.